Welcome to part 1 of Competency 15. In this competency, the teacher understands mathematical reasoning and problem solving. This competency is in Domain 5, which is 10% of your overall grade. In this video, we will work with direct and indirect proofs. Okay, before we begin, we need to talk about proof methods. And the two that we want to focus on are the direct reasoning and indirect reasoning. Okay, for direct, you're going to state a hypothesis that you know is 100% true. You say, this is true. And you go through connected reasoning that will, without a shadow of a doubt, be rigorous enough to prove that true statement. That is, believe it or not always the best way to go. When you are to the contrary or the contrast, indirect reasoning, it's easier. And I'll tell you why it's easier. It's easier to say, okay, I want this desired conclusion. So I'm going to say that it's false. By saying it's false, you go through your connected reasoning, and it's so obvious that it's incorrect in some way that you can say, okay, this is a contradiction. So something else must be true. And because of the given, this is true. And so you get to your conclusion because you see the given assumption, and then you can go to the right conclusion. Okay. All right. And then, of course, there are other methods along the way. There are counterexamples, which are really, really helpful, but that's not what we're going to focus on first. Okay. We're going to work with these two. And I'm going to tell you right now, for testing, I'm telling you, indirect reasoning is going to be your best bet. Okay. All right. So let's try some questions. Number 1, select the appropriate explanation below that describes an indirect proof showing the square root of 3 is irrational. Okay, well, indirect means we first assume the false, or in this case, the opposite. So if we want to say the opposite of irrational, we say rational. Okay. And think it also, if we say the conclusion is something even, a good assumption for indirect would be odd. Okay. But in this case, we just need to say that it is rational. That gets rid of A. A says, suppose that square root of 3 is an irrational number. No, we can't start with our conclusion. Okay. B, however, looks good. It says rational number. Let's look at C. Let it be irrational. No, we said do not start like that. So that's out. Let's look at D. Show a counterexample that shows a contradiction. Okay. In this case, counterexample is not going to help us. Okay. It just isn't. Okay. And good luck finding one. Okay. Either something is rational or irrational. Okay. It's like odd and even. So that isn't going to help us at all. Okay. I mean, I don't know. Maybe you could find something that would work, but I can't right now in my life think, for the life of me, think of anything that would work. Okay, so now I've got it down to B. Let's look at the second half. Then show this rational number leads to a contradiction. Absolutely, that is the definition of an indirect proof, and I have written this proof before for the square root of 2 and the square root of 3. Very common thing in proof writing. Until I got the hang of it, it was a struggle. So anyway, option B is exactly what we need. Okay, let's go to number 2. Number 2, in the following diagram, the measure of angle 1 and the measure of angle 2 are supplementary to each other. Prove that L1 and L2 cannot intersect. Well, that's the two lines. Okay, this is a very famous proof. You should all know this proof, regardless of if you are taking the high school or middle school exam. if you didn't learn this either at high school or at college, please get familiar with it. It's a very, very common principle. Okay. All right. So the first thing we're going to do is yes, it's going to be indirect. So it says they cannot intersect. Okay. If they cannot intersect, this means they are parallel. So they are parallel lines. So to make our assumption indirect, we must say they are not parallel, and they must not be parallel to intersect. Okay. And we usually how they do it is they stick a point out here, and then your instructor will draw some odd looking lines. They're very weird, and say somewhere down in the future, unknown area somewhere out there, it's going to intersect it at some point. And sometime, because we have B and C, we're going to have to call it A. Okay. They always do that. There's this unknown point way out there. Okay. So what we're going to do is look for anything that begins with the indirect. Okay, start the false. So we're saying that they are not parallel, and then it does intersect. That would be our assumption. And I'm looking at A, and that is exactly what it says. Assume that L1 and L2 are not parallel and intersect at point A. Okay. Oh, not sure why that undid. Okay. So that's where we need to begin. But let's look at our other things. Well, even before we move on, let's make sure that it says there's a contradiction. Let's look at the last sentence. There is a contradiction since the angles of any two triangles must be greater than 0. That makes sense. That there is a contradiction, and I've seen this proof, I can tell you how many times. And this is how this is the skinny of it. Okay. All right, so let's look at B real quick, and then we can come back to A and talk through it. Does B start correctly? Well, they say that the measure of 1 and 2 are equal to 180. Well, that's the given out of the statement. they're stating with they're stating the given, and then they're parallel. They're like going through and just giving you Captain Obvious. And actually, that's kind of like proving supplementary, kind of oddly and weirdly. So that has actually kind of has nothing to do with what we're trying to prove. So B's out. So let's look at C. Assume that L1 and L2 are parallel. No. Okay, and by the way, you've got to know this notation also. Notice those two lines, that means parallel. If you're not familiar with the notation, go get familiar. It's super important. Look at this right here. 1 and 2 are equal to 90 degrees. That's a simple property that you should know. Supplementary implies that they equal 180. If they equal 90 degrees, they're complementary. Therefore, C is definitely not a proof of anything. It's just, that would be some incorrect statement from a student. Okay. So now let's see D. Assume that L1 and L2 do not intersect. Okay. I'm buying that. Okay. Then the measure of 1 and the measure of 2, that's angles 1 and 2, are supplementary. You can't. Okay, no, it says a given. It says given that they are supplementary, then they equal 180. Well, that's like restating the definition. A supplementary is 180. Okay. Well, I guess they're giving us the numeric. This shows the conclusion is true. Okay, that doesn't show anything. That's just restating the obvious numerically. That makes no sense. D makes no sense. So let's go back to A. Because the introduction and the conclusion of A made sense. Okay. That they had a contradiction. Now let's go see if this really happens as we read along. Okay, point A, and creates a triangle ABC. Yeah, that'd be the next step with the measure of 1 and 2 equaling 180. Okay, so they're like kind of like setting it up. I agree with that part. The triangle ABC cannot equal 180 since the measure of 1 and 2 are supplementary. Oh, absolutely. That's like really huge. The given isn't going to work, which creates our contradiction if we truly had an intersection. This would mean that the measure of angle A equals 0. I agree. That's a short, quick, reasonable proof. I mean, I might put a little more in there. That gets down to the point. Okay, I agree with A. Okay, if you're not familiar with this very, very popular proof, it would be a good idea to go look it up. And I also want to point out something else. Notice I haven't used my calculator. Sometimes you will, just to check what they're stating. You might do a little adding and subtracting just to prove to see if something's incorrect while you're reading. But for this little section and these few problems, you probably won't use your calculator. But I thought I'd include them in my videos because I'm trying to be helpful. All right, let's go on to the next one. Number 3. In the following diagram, EG, that's the ray, EG is perpendicular to the line DF. So that means I have a right angle. And if that's a right angle, then this is also a right angle. Here, let me change colors. Okay, so we have a right angle here as well. And then over here, change my colors. Okay, we have another right angle. So this would tell us a few things as we move along, okay? All right, so prove that the measure of DEH is greater than 90 degrees. Well, that seems pretty obvious, but you can't just say it. You have to prove it, okay? Because a picture can be um, it can be not to scale or other issues can arise. Okay, so what we need to do is it just makes sense that we need to prove by contradiction, which implies the indirect proof. So look at what we need to prove. It says that DEH is greater than 90. So what we need to do is state the opposite of that, basically. And what is truly the opposite? Well, it would have to be less than. But what else could we say besides less than? We also have to say equal to. So we have to say less than or equal to. So we assume that that is a measure of DEH, okay? Well, that gives me A. I like that. So let's go down and look at the others. Let's start at D. Let's eliminate D. Assume that the measure of, that's a given. That's not going to work for this type of proof. And you should be very used to this proof. It's another popular one, okay? That just isn't going to work. Just not copacetic. And let's look at the last part of it. It says, this shows they create an assumption. So what are they saying it shows? Then the measure of DEH equals 90 plus DH, which implies that no, this part right here, this is not true. This this is not going to show it. This is a contradiction. That gives us our contradiction. If we have 90 degrees plus the GEF, then that implies that GEF equals DEH minus 90. Okay, that doesn't show. It actually shows that it's less, not greater than. Okay. Uh, yeah, DEH minus 90 equals GEF. Okay, that would be true, but that's a contradiction. That's not going to help us. Okay, so let's go to C. Oh, they're doing the same thing. I disagree. And let's look at the line. They're using the measure of DEH equals 90 minus. Okay, that's not true. This is just a false statement right here. It is not equal to 90 minus this. Okay. Yeah, it might be true for something, but not for what our image is, or not what our given is telling us. So that's not going to work. So now let's look at B. Let's see. And with these, it's best to pick through them like this instead of reading the whole thing. Pick through what doesn't make sense. Well, the first thing I want to look for in B is I'm going to say I don't like the start. Okay. And then I'm going to go down to these other. I like the fact that it says it's a contradiction. Okay, fine, which is what A says. A also says this is a contradiction since an angle must be a positive measure. Okay, I like that. However, it says that, well, I add okay. I don't like this part right here. It says then the measure of DEH equals 90 plus GEF. Okay, that's just not true. Okay, let's see. This is the angle right here, DEH. That is 90 degrees plus GEH, not GEF. Okay, so that's an untrue statement. That statement alone is incorrect. So now let's take a look at what A says all the way through. By the addition rule of adjacent angles, the measure of DEH equals the measure of DEG plus the measure of GEH. That is true. I agree. Keep reading. Since it is given that EG is parallel to the line DF, okay, and that is true, it's given, then the measure of DEG, okay, equals 90. Very true. So the measure of DEH equals 90 plus the measure of GEH. Very true. Which implies that the measure of GEH equals D DEH minus 90 degrees. That's very true. However, this is a contradiction since an angle measure must be a positive measure. Okay, and what that means is that it's got to be greater than 0. And from this, given, oh, wait a minute, okay, DEH minus 90. Okay, DEH. Yeah, so it's saying it's greater than 90 and then minus 90. Okay, but we're saying that DEH is greater than 90. Okay, oh, because we started out saying, okay, that's where it is. Okay, woo, I lost myself for a second. We're saying that it's equal to or less than, I was right. I was right in the first, my first statement. It isn't this part right here. It's our assumption here. Let's see if I can get this to, okay, there it goes. It's the assumption that we made. If we use our assumption, that would be less than 90 minus 90, which would give us a negative angle measure, or it equals 90, which is 90 minus 90, which is 0, which is our contradiction. So we did, A is the correct, uh, it's a correct explanation of a proof. I wouldn't say it's a full proof, but it's a very good explanation. Okay, so let's move on to number 4. Number 4, in the following diagram, triangle ABC is scalene and AD is perpendicular to BC. Prove that BD is not equal to BC. So BD is not equal to DC. Okay, if this is scalene, okay, those are not equal, but we also know that this would not be equal either. Okay, even if you added, uh, all the, let's just say that this would not be congruent either to B, A, or A, C. That's what scalene means. All the sides are not equal. Okay? All right, but we have to prove that. Now, what is the opposite of what is given? That's what we need to start with indirectly. It'll be much easier. Well, we need to start with BD is equal to DC. Okay? So here, I'm going to put a not equal. That's not equal to the other sides by definition. Okay, so that eliminates A and B. They're gone. They don't start correctly. Okay, regardless. All right. So now let's go down and look at CD. Not too far down because we still need to see our image. Okay, so C starts correctly and it says BD equals DC. Since, okay, AD is perpendicular to BC, that was given, that is true. And because of that, we have the measure of ADC is equal to 90. Yep, that would be very true. That's 90 degrees. And we would know that AD is equal to DA. That's a little trick by the identity postulate. Absolutely. That's a little trick we use in geometry, geometric proofs. Okay. So then triangle ADB is congruent to triangle ADC by the side angle side, which implies that AB is equal to AC. I see what they're doing. Okay. Since corresponding uh, parts of congruent triangles are congruent. Okay. However, this is a contradiction, and that's not what's true. Now, we're saying it's a contradiction. All right, and we're looking at a picture that truly gives it to us. But we know by all of these conclusions that it's a contradiction because this is scaling. So that's simply not true. And I'm going to agree with C, but let's see what D says. Um, it's saying that, let's see, it starts out good, it starts out the same, but it's automatically going to, which implies that the two triangles are congruent, and then AB is equal to AC. Okay, they skipped a very important part, which is this little stretch right here, this little statement right here, this little phrase. We have to include that phrase. So that means that D is incorrect. If you're not familiar with these, I have another proof also. These are really popular proofs. So if you're not familiar with this or it's been a long time, go brush up on these. Go find, there's some good sites out there that go over very popular triangle congruencies. Okay. All right. And just how do we get there and what should it look like? Okay. Let's go to the next one. Number 5, in the following diagram, GF is a chord of circle E, but it does not contain the center of the circle. What would the steps be to prove that GF is less than the length of the diameter? Okay, in the next image, I added that and I drew what they are saying. I drew in the diameter. Okay, so that diameter is called FH. So what are we trying to prove? We are trying to prove that GF is less than FH. Okay, all right, so that's what we're trying to prove. So if we're going to start an indirect proof, we need to say either greater than or equal to. We really can't say both in this situation. Okay. All right. And I drew in the triangle. Why did I do that? There's a couple of reasons. Uh, First off, we can have a comparison, and that gives us another angle. And there's a whole lot of properties going on. The first huge property is that this arc, oh, here, I needed the highlighter. This arc from F to H, that is going to be 180. And because that's 180, this angle created at G when we drew in our triangle, that is always going to be half of that 180. Therefore, it's 90 degrees. And if you move the point G along the circle, it will always be 90 degrees. Very important point. Okay. All right. So that being said, here, let me do this. Let's look at how we need to start. So we need to have either something greater or equal. Okay. Well, A and B, they start out perfectly fine. I like this. I like this. Okay. Now let's look at C and D. How do they begin? Well, C, it says greater. I'm okay with that. Yeah. Okay, but D says less than. Okay, that's what we're trying to prove. And I'm not going to like it for another reason. They're saying it leads to a contradiction. Well, our assumption is what we're trying to prove. We can't say that we're trying to prove what we're trying to prove and then say that it's a contradiction. That disproves it. Okay? So that's one reason I don't like it. Now let's look at C. Let's look at the end of it. It says this proves the assumption. Okay. Um, that G is greater. Okay, but we don't want to prove the assumption. We want, that's not the assumption we want to prove. That would all be a contradiction because look at what it's saying here. It's saying that angle FG is greater than, arc. I'm sorry, it's not angle, it's an arc. They're saying that this shorter arc is greater than the FH that we had just talked about being 180. So any other arc, when you divide it up, is going to be less. So that is a contradiction. And it doesn't really prove our assumption. And even if we prove our assumption, we're not proving what we need to prove. So that's just a bad proof all the way around. So I'm not going to believe C. Okay, so let's look at A again. Ah, okay. Well, no, before A, let's look at B. It says leads to a contradiction. I like that. Now let's look at A. This proves, oh, look at what it did here. Less than proves our assumption. Well, our assumption said they're equal. That just flat does not prove the assumption. That is a bad proof. Okay. Notice that I am not going through all these. And again, I'm not using my calculator. Every now and again, you will need to use your calculator. One way you might have to use the calculator is if they gave you the measurement of the angle and you use some property to get what that angle would be, half of it or something. But we're not using that here. So let's look at B. They go through and they said, show that the measure of H is less than the measure or greater than the measure of G. Well, you could try to do that. There is a way to do that. Since the measure of an inscribed angle is half, thus, okay, if you did that and you proved it, which you could, there's a way to prove this, then this would happen. But this would be a contradiction. It would just be a fallacy. So I would agree with option B. Okay, this is the last question in this video. Once again, thank you so much for making it to the end of the video. This is a lot to take in if you're not a geometry person. It's a lot of spatial things and a lot of properties going on, and very little calculator use, as you saw. And thank you for liking, sharing, and subscribing. You guys are the best. Happy testing, everybody.